Okay, so moving on to the last question, question 15. Yes, this is the last one. Okay, the two blocks on a frictionless plane are connected by a light cord passing over a frictionless pulley. Okay, so the plane is frictionless. Okay, so it helps a lot. Okay, now I can try to draw the free body diagram. The question asks you to draw the free body diagram anyway. So to answer that one, I draw that one first. So I have two objects right over here for A and for object B. I'm running out of space, so I just write it like that. Okay. Now, if you want to sketch a little bit over here to identify the direction of the to identify all types of force, so you have weight. Weight is downwards like that. Weight A, weight B, normal A. Sorry, that one's normal B, normal A. Okay, I think I have to draw it properly. Okay, now it's frictionless, so you don't have any friction, but you do have the tension, which is always pulling away from the object. Okay, regardless of the motion, it doesn't matter whether it's moved in this direction or in that direction, the tension will be in the string, on the string, and it will be pointing away from the body. Okay, now if you want to determine which side we go, you just have to look at the mass over here. So one is 100 kilogram, other one is 500. So you expect it to move in this direction lah. It even gives you the direction over there, so you just follow. So let's say if you don't know, we assume first and then see the answer whether it makes sense or not. But in this case, they do give you the direction, so it should be okay. Okay, now for object A, I have 3 force. Weight in downwards, and then I have my tension in that direction, and my end will be in that direction. Similarly, I have this, and that. Okay, let's make this one shorter a little bit. Okay, just adjusting a little bit. Now it's time to label. Okay, don't forget to put the arrowhead. Okay, this one is your T, this one is your NA, and this will be your weight A, weight B, normal B, and then tension. Just double check. Okay, if you draw it like this, it's not enough because you didn't indicate the angle there. So that I always told you, if the angle is from the inclined plane towards the horizontal plane, then it will correspond to the angle towards the y component of the weight, which is over here. Okay, so I just use the same color pen. But wait, I think I mixed it up. So this one is basically your x, right? It's for this one. So A will be in that direction, and in this case it will be the x component, so the angle will be over here. So if you're not sure, okay, you can always double check lah. You can try to draw the triangle and see how it goes. In this case, for object B, okay, again will be in this direction over there. So this will be your 53. Okay, again, if you're not sure, you can always try to draw lah. I think it's correct. Okay, what else? Okay, indicates the direction of A. So if you're following this arrow, so you expect A will be in that direction. This is your A, and so this one goes down over there, A. Okay, you sketch the free body diagram, calculate the acceleration of the blocks. So if I want to think the acceleration, I didn't know the tension. Okay, so these two tension is on the same rope or on the same string. This one chord lah, on the same chord. So you expect that the value will be the same. So if I can write down one equation over here that have T and A, and one equation over here that has T and A, so I can find the T and A because I have two variables and two equations. So to do that, I think I'm gonna do the X component only for now lah, and then we'll see how it goes. Because it doesn't have any friction, I think it's enough, but we try it anyway. So M1 MA A, this one's for MB A. Okay, so I'm gonna solve this one a little bit down here lah. Okay, over there. So now all the X component exists. Sorry. So for object A, my acceleration, it will be in this direction. Okay, so if you want to solve, I always told you, try to redraw the diagram because you want to resolve it, right? It's up to you. You really can just draw it over there, it doesn't really matter. Maybe I draw it in the new page instead. Okay, so for this is for question B. Just erase this one. Okay, the mass for A is 100 kilogram, the mass for B is 50 kilogram. Mass for A is 100 kilogram, mass for B is 50 kilogram. Alright. Okay, looking at this direction of A, so you expect that this is positive A. I can write this one of summation of Fx equals to MA. I just rewrite this one because it's on the new page. Oopsie. So it will be negative T. Why negative? Because it is in the opposite direction of the A just now. A to the left in this case, and T to the right. So T is negative. I put T as negative. And don't forget, you do have one more force. Okay, again, if you didn't resolve, you wouldn't know. So after you draw the free body diagram, before you calculate or before you substitute the equation, the one thing that you guys need to do is that you have to look at this diagram, okay, and then see which of these force that is not on the axis. Okay, so this one, like I always told you, if this one is acceleration in that direction, this will be your x axis, okay, and this will be your y axis. So the WA is not on the y or x, so you basically have to resolve into WAX and WAY. Now it makes sense. Then you can see that why the y component can be balanced and why it can move in that direction. So it will be WAX, okay, minus T. And you do have the M, you can write this one a little bit further, mg sine theta minus T is equals to 100A. Again, you can try to substitute a little bit. So this one is 100 multiplied with 9.81, so get 981 sine 30 degrees minus tension equals to 100A. Okay, again, I try to simplify a little bit so that when I try to substitute or solve, it becomes a little bit easier. Sine 30, so that 490.5. Okay, minus T equals to 100A. So this is my first equation. Here for object B, right over here a little bit further. So I'm going to bring this one further to the right as well. So this one is equals to fx equals to mba. So again, before you write down the equation, identify in this diagram, is there any force that is not on the axis? So you can see that this one is not on the axis, WB. So that one's because you have to resolve lah. WBX and WBY. Okay, now you can solve it. WBX minus oopsie. Let's erase this one a little bit because I can mix it up with the diagram. Okay, so this would be my x and this will be my y. Okay, I just realized that A is in that direction. So then, so fx will be tension minus with WBY, which is mg, and m correspond to mb, will be sine 53 degrees equals to 50A, because the mass is 50 kilogram. Okay, so we are talking about this as your axis, because this is your direction of A. Excuse me. So you have T and WBX. So the one that I resolve over here is actually WBX. So that's why it becomes mg sine, because the angle is over there. So it's further away, so it's sine. So T minus 50 multiply with 9.81 sine 53 degrees equals to 50A. Again, I try to simplify it a little bit. I got here is 391.73. So it will be T minus 391.73 equals to 5A. It's not 5A, it's 50A. Okay, so now I have two equations, okay, and I have two variables that I need to find. So the question want me to find the acceleration first. Okay, so if you want to follow the question punya questions, find the A first. So you use T equals to 490.5 minus 100A. So this is the values that you will substitute inside the equation 2. So substitute 1 into 2. So now what do I have here is 490.5. So basically I use this equation, and I just substitute the T with this one. So masuk inside here. So now I have 490.5 minus 100A minus 391.73 equals to 50A. So you can bring the 100 to the other side, so it becomes 150A. 490.5 minus 391.73. I got here 98.77. So my A now becomes 0.66. Okay, once you get the A, it's become much more easier lah. Calculate the tension in the chord. So question C, they want you to find the tension, so you can choose any formula. So I just use the first formula, substitute into 1. So now I have T equals to 490.5 minus 100A, which is 0.66. So basically I have 66. Oopsie. So 100 multiplied by 0.66, and then 490.5, oopsie, minus 66. 424.5. So the answer might vary a little bit if you choose a different decimal place, which is okay. So as long as you press your calculator exactly what you wrote, then it should be okay. Okay, I think that's it for tutorial question discussion. And after this, you can try to do the passing. Okay, thank you for watching.